So in today's video I want to address the issues around the Arduino Nano nodes. Now obviously you'll see here I'm powering the Arduino Nano through the 2.1 jack on the shield. Now this worked okay except for we see when I added the extra infrared detectors we started to see some brownouts due to the voltage regulator that's built into the board. There is a workaround for this, which I'll show you now. So on my load, I have repurposed an old power supply from a gaming laptop, not this particular one, which then I plug into one of these units here. Now this allows me to change the fuses in it to set the actual maximum amperages, but this gives me access to 3.3 volts, 5, a minus 12 which I don't use, and a plus 12 volts. I've then used suitable gauge wiring to run the different buses around the layout. So you did see me using the 12 volts section, but what I'm going to do next is use the 5 volts and go directly to the Arduino shield. I could of course use something like this simple buck converter here and use just one bus going around the layout, i.e. 12 volts, and then step it down to 5 volts. But I feel I'd rather run a separate bus around for 5 volts. At least I know PC power supplies are normally pretty robust compared to something like this small module here. So this will now supply 5 volts for the Arduino Nano that it needs to be able to run, as well as the peripherals that I want to plug into it. Now obviously you've got limitations to depending on the size of the wire that you've used, but for what I've been showing, the likes of the 3 servos and being able to put possibly a few more of the infrared detectors on this way will save me a little bit of money. I will at some stage put this onto a scope to see what sort of current draws we are seeing. So the other limiting factor of the Arduino Nano in my opinion is it's working for me because I use the blades from the turnouts to supply the power to the frogs. So yes, we can do that with the Arduino Nano, and we can do the simple IOs that we've shown within the sketches so far. However, for people who want to change the frog using a relay or a frog juicer or some other type of equipment, I think we're really going to have to move it over to an ESP32 or a Pi Pico at this stage. So I'd like to point you out to this GitHub repository of John Callingham. Now John has created 2 sketches so far for the Pi Pico, and this is one for 4 servo and 4 frogs. So the code is in here. He's actually done it using platform IO, so you'd have to learn how to use that, although we are looking at adding the Arduino IDE version of it as well in the near future. And then this one here, again this is for using the Wi-Fi. He's created 4 servo, 4 frog, and then he's added 2 crossovers. So again, I haven't personally tested this yet, but this is nice to see the progress John has been making with the project so far. I believe at the moment he's also working with some time-of-flight sensors for another bit of a project that he wants to bring to his layout. And currently I'm working on the ESP32 with the original 2 servo, and I push this now up to 15 IOs. But you'll see a red arrow on the shield. Now at the moment I've got this set to 3.3 volts. You can change this to 5 volts, and that will then put 5 volts on the V rows, but I'm keeping it at 3.3. Now there is a bit of a strange thing here. I've got this where it will control 2 servos at the moment. Now the servos, the SG90s, normally state they run at 4.8 volts to 7 volts. But I've been seeing that we can get away with them on 3.3 volts. We did a quick experiment the other day with a controlled power supply, and 3.3 we were okay. Anything less than that, and you won't get any movement. But we also did notice it didn't seem to affect the amount of torque you got or the speed of the servo. So we're still experimenting more with that to see how reliable it's going to be. Anyway, I think I've rabbited on for enough today. So thank you again for the people who've raised some questions to me, which I will respond to very shortly. And thanks again for all the people who are liking the videos. And I'll catch you again soon. Bye now.